Okay, then I'm gonna try to do a whole paper.
No, focus on the mole.
Focus on the
Mole. Mole questions.
more questions. Okay.
Share your screen and let's pick the mole question together right now.
Oh wait. How does that? Okay, then I'll join Zoom on my laptop and then show.
Oh, all right.
Yeah.
Let me confirm that mole question is part of the exam.
Yeah.
Okay.
Can you see my screen?
Mm-hmm.
Okay, let's just do 27 because we've done a lot of questions from the periods before.
Mm-hmm. This is M. No, this one. Wait, this is MC.
I need to move the zooms.
What is this? What is an MC? Never mind. Okay. Skip all these things. Oh, there you go. Last one.
Yeah.
All right. Let's practice this one.
Are you gonna get all the questions first? Or
Yes.
okay.
Skip this one.
This is not tested.
It's all camp.
Oh.
Yep. Yep. Go. Wait. Quickly go down. Quickly go down. No, you can go down. Then that's it. Okay. Next paper.
There's a more recent one. There's a 22.
Come to common test. Yeah, doesn't matter. Yeah, moving around, moving. Stop. Oh, never mind. Okay, never mind.
Oh yeah, what is this? What is a salt bridge?
If your teacher don't teach you, right?
To be fair, she doesn't teach a lot of stuff that comes up. So, but I'm pretty sure this is tested because the last two test papers all had this.
Get your Jamboard notes and copy this thing.
Okay.
Yeah, put that question in the Jamboard also, but in this Jamboard, you're accessing your chemistry note. Right?
Yeah.
Okay, then put that question in our discussion Jamboard.
There you go.
Now the question say this is a change of setup. Let's put in the original setup first. Yeah, should be this one.
How about should I just do the whole question? I'll copy the whole question. I only have the questions.
I give you 5 minutes to do the question, yeah? Until the salt bridge part. Ainesh, what chapter is this question?
Battery.
All
My
right.
battery is. I'll try first.
Mhm.
What? What does negative voltage mean?
Positive voltage means you insert the battery correctly. Negative voltage means you insert the battery in the opposite way. Something like that. Does that make sense?
So it means that Q is more reactive than iron.
Iron, you mean? That is a good conclusion.
Let me do B first.
Do zoom in a little bit. Your question B is already correct, but I cannot read your question A.
Yeah. Can you read?
Ah, wonderful. Yeah, okay. The equation is wrong. Ganesh, your equation is wrong.
Oh. I have to give a charge, right? Oh, x plus. Will that work?
Wonderful, wonderful answer. Now, with the exception of who?
Oh, q.
Yeah. No. That's it. Okay. Okay. Now, the salt bridge has nothing to do with part A and B. Part A and B is a simple battery. So, well, how do I say? Does not. The salt bridge changed something very specific. So let me show you lah. Okay. Do notice a few things from the simple battery. Sulfuric acid is not a good idea. It works, but it is not a good idea for a battery. Do you know why?
Because SO4 doesn't react.
I'm sorry, what? Sorry?
Because SO4 doesn't react.
Doesn't seem to be a problem most of the time, right?
Yeah.
For you.
I was just shooting it up.
I know. Use your logic.
Why is that an issue?
Yeah. Why is that an issue? It will cause some problems, practically.
I mean, because the metals could be below hydrogen in the reactivity series. It could be gold or silver.
And sorry, why is that a problem? Sorry.
And then hydrogen could react instead of the metal. Does that make sense?
Wait. Check your logic for. You're saying that the non-reactive metal, gold, right? Non-reactive. The non-reactive metal will react with acid, but the more reactive metal will not react with acid, huh?
Wait, gold is non-reactive.
At this point of time, you are still asking that gold is not reactive, really.
Oh, I didn't know that. But silver is, right? So what if it's silver?
What do you mean by silver is reactive? Well, who is more reactive, silver or, for example, iron?
Iron.
Yeah, iron. Yeah. Who's more reactive, iron or silver?
Iron.
All right, you're correct. Who's more reactive, silver or sodium?
Sodium.
All right, and who's more reactive, silver or copper in this case?
Copper.
Right. So why is silver reactive again? I'm sorry. I mean, silver can react, but is it relatively reactive?
No, never mind.
Then gold even not more reactive, right? So you may think that is good or bad depending on what you want. If you want a ring, I think it's a very good idea. You don't want a sodium ring. I mean, right? You don't want that. You also don't want a lithium ring. You don't want that. You'll burn your finger. But you want a lithium ion battery. And the reason is because lithium is rather reactive. So you want a battery which is reactive. It's dangerous, but it is desirable. Now, sulfuric acid, you are saying is going to react with the not so reactive silver and gold. Are you sure? But not going to react with the more reactive metal, everything else on top. That's your logic right now.
No, I take back what I said.
Change it.
Dilute sulfuric acid.
I mean, when you learn in what you learn in acid is pretty simple in summation. Acid will react with
the metal. Oh yeah. Okay, so there could be like a side reaction where the acid
which is like that's helpful or that's messing things up for a battery. Agree. Even the iron electrode will react, The iron electrode will definitely react with sulfuric acid. So if you're just testing for 5 minutes, who cares, right? Who cares? Even then already, you'll see some bubble in the iron electrode due to the reaction with iron electrode, which is very, if you think about it, it's a very bad experiment. You don't know whether the reaction is because of, the battery working or it's because of the acid working. We are not trying to test whether the acid is working. Sulfuric acid is in general a bad idea because it reacts, right? In general, right? So there you go. That's the practical reason why we don't use a lot of sulfuric acid in battery, but it does work when your battery only needs to last for 5 minutes. Now, look at the setup. The setup change is not just the salt bridge. The setup change is that you no longer use sulfuric acid. Just notice that. What do you use?
What does that say? I mean, it uses two different things.
Right, which is of course rare, right? Because for some reason, you now have two beakers. They are now separated, which is something that you rarely see. But you only see this in the salt bridge setup. The salt bridge setup separates the anode from a cathode, meaning separates the electrolyte of the iron and electrolyte of the copper. And then you put a salt bridge to connect them. Whatever that means, that is what salt bridge is going to do, right? So you have two different electrolytes for the anode and the cathode. That means you don't have three beakers. That also doesn't make sense. You don't do that with a salt bridge. Just have two, or one of each. All right. Why is that so? We'll talk about it very, very soon. So far, so good in the setup?
No, I don't really understand.
Of course, but you can see the difference in the setup, okay? Two different beaker, one for anode, one for cathode, and they are no longer filled with sulfuric acid, which is misleading. It is now filled with, not surprisingly, FeSO4 for Fe and CuSO4 for Cu. Again, we'll talk about this very soon. All right, Kenya?
Yeah.
So, salt bridge is something extremely simple. First of all, if I don't have a salt bridge, the battery is disconnected, so it doesn't work. But I want to connect them not with a wire at all. I want to connect them with a salt bridge because the electricity in the solution is never a flow of electron. This is something that you struggle to understand back then. So one more time. I'm going to repeat the foundations. The electron flows from here to here. By the way, how do I know?
Because the more reactive metal is the anode.
And the more reactive metal does what?
It flows from the anode to the cathode.
No. The more reactive metal don't flow from the anode to the cathode. It does not.
I think the electron flows from the anode to the cathode.
Right. So are you saying that this is the anode and this is the cathode? Is that what you're saying?
Unless it's
right?
Q. Yeah.
Unless it's Q. We're going to take off Q for a while, which is anomaly. So at this point, I do make a slight mistake. Your answer is totally wrong for the reaction.
You mean this one?
Yeah. Just based on the electron flow, which you never do one unless I say, which you never do, right?
It should be
List down the candidates in the cathode list.
what am I doing?
Hydrogen plus is not gas. What are you talking about?
Wait, hold on. Let's read that. H.
What's the candidate? Sorry, is the candidate H or what? Sorry.
H plus.
All right, so that will be better, right? Except for Q again, except for Q. In Q, then I think your reaction is correct. Right? So the electron flow is like this, but electron has to complete a circuit, and very surprisingly, in the solution, no electron flows because electron cannot even enter the solution naked. Electron travels on wire, does not travel on solution. Even though we say solutions conduct electricity, he does not conduct electron. The solution conducts negative ions. Look, let's put it that way. So negative ion will go from here to here. Look. Something like that. Something like that. Instead of electron, it's the negative ion. Okay. So the salt bridge allows the negative ion to flow in order for the circuit to be complete. First thing first, negative ion will flow here, and hopefully, not to your surprise, the positive ion will flow there also. That's what the salt bridge do. The salt bridge becomes a conductor for ions, so to speak, so that the circuit is complete. Am I making any sense?
No.
One more time.
Okay.
If there is no salt bridge, what will happen to the battery?
The circuit is open.
And what will happen to the battery?
It won't work.
Correct. So can I connect it with a wire?
No.
Why not?
Because electrons don't flow in the solution.
So therefore, if the salt bridge is a wire, so let's pretend that it's not a wire, you still have a problem where?
The electrons don't flow.
Where?
In the solution.
Correct. So it doesn't solve anything. If you connect the wire with the metal, then you no longer have a battery. Look, that's just nonsense already. Look. Then you don't need a solution already. Then this is not a battery and you won't generate your voltage. So the salt bridge, I'm sorry?
No, yeah, I agree.
So in general, the salt bridge is to keep the two separate solution connected, like the one previously. Sounds like I'm creating a problem and then I try to solve it. Sounds like I caused the problem and I try to be a hero. Sounds like it's a waste of time, something like that. But bear with me for a while. That's what the salt bridge do, to connect the separated solution, because we realize that the solution cannot truly be separated. Right? So it goes to say, why you create a problem by separating the solution in first place must be something to do with having two electrolytes, which is not achievable with one beaker, which is not achievable. Back to the salt bridge, that's all the salt bridge do. That's all. The salt bridge connect. I'm sorry?
But how does it do it? Do we need to know that?
Oh, yes. I'm going to explain now, and then should be clear at that point, right? Okay. Aditya, I can see you, yeah? So again, I promise you, the salt bridge job is to flow the negative ion like this. That's the circuit. And the positive ion is always the opposite, just like what happened in a single solution. That part at least can accept personal.
Yeah.
And then I'll show you how it works, lah. Not very complicated, right? Aditya, I can see you. Aditya, can you hear me?
Yeah, hi.
All right. Okay, wonderful. Aditya, give me a quick update using the Jamboard and tell me whether you are still in the middle of exam. So tell me your exam situation. All right. I have to explain something to Ainesh first, then I'll go. Right. Okay. So now Ainesh, very, very simple. Huh? The electron comes in here, right? And the electron goes out here. Correct?
Yeah.
To keep it very simple, the electron will somehow enter the solution as a negative ion or as a disappearance of positive ion. Look at what happened. Isn't it true in the copper side, the positive ion disappear because he is forced to accept electron? That's your hydrogen gas, correct? Correct. Your reaction say 2H plus 2 electron, totally correct, and become H2, the disappearance of positive ion because forced to accept. Make sense?
Yeah. Yeah.
That's just what happened when a solution, so to speak, accept electron, either generating more negative ion or eliminating some positive ion. Therefore, the beaker 2 will have an excess of negative ion compared to positive ion, whatever that might be. That makes sense?
That's the case for every electrolyte, right?
Works for every electron, correct. How can you accept the electron, then become more positive? That is just not sensible at all. Correct?
Yeah.
Same thing with beaker 1. Beaker 1 is where the iron is forced to. Can you hear me?
Hello.
Can you hear me? Can you hear me? Ainesh, can you hear me? Yeah, which Jamboard are you using?
I made a copy of today's one and I sent it to you.
The Tuesday night up. You're referring to today as 9th May, right? So I'll just change it to 10 May.
Hello. Okay. I'm not sure what
Ainesh?
my phone got hit.
Yeah. Can you hear me?
Yeah, let's just talk to the laptop for a while first. Let me understand the salt bridge.
Sure. Right. So same with the beaker 1, the ion is forced to, eject electron to the wire. So beaker 1 will have an excess of positive ion, something like that. Correct? Yes or no?
Yeah.
Right. Which is what is happening in normal battery. This is not something not happening normally. It just happens. It's just that in a solution, they will balance out. They just, oh, you have more positive, then, you will automatically attract more negative ions there. Oh, you have more negative ions, then you will automatically attract more positive ions there, no? Right? Excess negative, excess positive will, through the salt bridge, cause the negative ion excess to flow like that, and the negative excess positive to flow like that. Finish, no? That's what the salt bridge do. It balances out the positive negative ion concentration, which is, for whatever reason, it is good for the battery because that's what's normally happening in a normal battery, in a single solution battery. Again, salt bridge is just solving a problem that the thing seems to create in the first place. Nothing actually new. Does this make some sense?
Okay, let me run through what I understood. So iron is the anode and copper is the cathode. So electrons flow from positive to negative.
Makes sense.
So then the electrons flow from iron to copper and then through like beaker 2 to beaker 1 back to iron. So
No,
the
electron does not flow from beaker 2 to beaker 1. Please don't say that. Only through the wire. Negative ions, right? Yeah.
So then wait, so electrons change into negative ions?
Yes, or eliminate positive ion, which is equivalent to increasing the negative ion. So to speak, in your reaction, you're not creating any negative ion, correct? But you're eliminating a positive ion, a H plus, or 2H plus in this case, which means there is now an excess of negative ion compared to the positive ion, which is kind of equivalent to creating a negative ion. I know. Does this make sense? I'm not speaking philosophical here. Does it make sense to you? Okay, Aditya, I'm following your gem. And are you okay, Anish?
Okay. Not super clear, but enough for tomorrow.
Enough logic, right? So what does the South bridge do? Allow the flow, If not, the negative ion will be stuck in beaker 2 with stopping the battery kind of consequence. Same thing with beaker 1. The positive ion will, pile up in the beaker 1, which again have the same consequence as stopping the battery to work. If the battery can even work in the first place without the South bridge, which the South bridge is needed for the working. So yeah, that kind of thing. Okay.
Okay.
Right. So now describe what will occur in beaker 2. That's C1. Surprise, 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 surprise. You don't need to know South bridge to work it out. You really don't at all. That's why I'm very hesitant to explain South bridge. For most of the time, the supernormal things happen because South bridge is to normalize things. Just make a guess what will happen to beaker 2 without even thinking about the South bridge. Meaning, just list down the candidate and what happens. Figure it out.
Yeah, okay. Will occur in beaker 2. Electron excess.
Aditya, if you could go out, go in, in your typing so I can follow first. All right. Right. The sickness that everybody's getting, right? It's not very nice at all. Yep, I understand. Wait, you haven't had dinner, Aditya?
No.
Uh, are you allowed to have dinner in your room?
Yeah, but like I gotta eat with my hands, so
I
I'll
know, I
probably
know.
just do it after class.
Just eat first, okay? No, please, just eat first. We cannot. We probably cannot. Our subject probably cannot be studied without full stomach. So right, okay.
Okay.
Understand on your sharing. Good. So Ainesh, I mean, I'm not seeing any video right now. Yeah. So I mean, what's happening in Beaker 2? We don't have much time here. Yeah.
Oh, sorry. I was writing
What's
the
going on here?
See, I forgot about that. Okay, then I'll just read out what I wrote.
No, just turn on the video. Come on. Stop. Okay. Right. Anish, why are we waiting for the video? Why do you create? What's going on here? Come.
My phone crashed, so I have to like just restarting us.
Hey, okay. Oh, right. Oh. Read for me the reaction.
Okay, I'm back here.
Okay, zoom in, please. Okay, understand, Aditya. So, what do we study today?
We can do applications.
Meaning to say what? Tangent normal. That's one. What else?
Tangent normal is pretty okay actually.
Okay, then what other application have you learned?
The minimum and maximum stuff.
Min-max, but the connected rate of change?
No, not yet.
All right. So only two, right?
Yeah.
All right. Let's do that, and you get a dinner, you eat, and then let's do it together. All right. Quickly. Okay. So, Ainesh, the reaction, please.
I'm very confused. What is going on? A potent
The rea-
solution.
Look, ignore the salt bridge. Really.
But it
Just
says the chloride solution in the salt bridge is replaced by sugar solution.
look, part one, the reaction. I'm asking for you for part one reaction.
Oh, I have to say that.
Yeah, totally great, right? Totally great. Are you sure it's balanced? Just checking. Right. So the potassium chloride in the salt bridge is not supposed to participate as a candidate. Never mind how that is done. Never mind how salt bridge looks like. You have never seen it in a lab, right? But the potassium chloride will not participate at all in the solution, even though the salt bridge is immersed in the solution. There is a way to do that. I'm not going to explain that. So the potassium chloride inside the salt bridge will never, so to speak, leak into the solution. That's a lot of explanation for something which is basically inert, right? But must still do the function of, letting ions flow. Is this okay, Ainesh?
No,
I
I'm
cannot
sorry.
hear you.
I'm still confused.
The potassium chloride in the salt bridge does not matter. Titik. That's it.
What? It doesn't matter.
I just told you.
How? Why?
This is not gonna. But as per usual, your timing is very bad. As per usual. This is just as per usual. This is just as per usual. Wait, why am I surprised? Okay, there you go. There you go. Okay. I'm gonna show you what salt bridges are made of. Can you see? Can you see what I see? Gelatin. Okay.
Did you insert anything? I don't care.
Share
Oh.
screen, please. Can you see the gelatin?
Yeah.
Right. Never mind what it is. You see the cube. You see the gelatin and white powder, right?
Yeah.
Right. So simple stuff. Simple stuff. He is going to. I mean, you know what's gelatin, right? It's just like the jelly, lah, right? It's just jelly. Okay. That's all. So it's not even a special jelly, and then he's going to do something else with the white powder. Now he's going to take the white powder, which is the electrolyte, no, the salt, right? And he's going to mix it with the gelatin. There you go, because the gelatin is inside the beaker, right? Very simple, right? Take gelatin, take salt, mix them together. Correct? In your case, that will be the potassium chloride, no, not the CuSO4, not the FeSO4. Are we clear?
Yeah.
Are we clear?
Yeah.
Right. Then he's going to add water, right? Because that's how you make gelatin, right? So yeah, gonna weigh water. He's not give he show how to add water. Whatever, he's going to add water, right? He's going to add water, and then he's going to put it in the pipe. Show it, please. Don't take so long to do something so simple. There, he put the pipe now, and I bet he's going to pour the gelatin in. There you go. Yeah, he's putting the gelatin in, right? Okay. What does the gelatin contain? Remember, the gelatin contains one thing.
Contains protein.
The white powder, the white powder, right? The white powder. The jelly is mixed with the white powder, which is the potassium chloride. Okay.
Yeah.
While still in liquid form, he put it in the tubing, which will become the salt bridge. Right? So the tubing is filled with the gelatin plus salt solution. What is it? Which is there, right? There, filled with that, and then put it in the freezer, let the thing do the work, and then you now have. There you go, something like that. So you have a jelly mixed with potassium chloride here in a tubing. There is your salt bridge. Okay. Ainesh, you asked for this. I know this will be confusing, but the more we talk about it, the more we don't practice other things. So please be quick. I know this is confusing, but I warned you before.
Okay.
If you want this, just be quick, please.
Then never mind, you don't go through this.
Can we just move on?
Okay.
Then just never mind the salt bridge, okay?
Okay.
Just do other questions.
Okay.
Aditya, have you eaten? Are you still eating?
Okay, then
Aditya,
we'll
can you
take
hear
like
me?
a 5-minute break first and then come back.
Yeah, my mom is
I'm-
bringing something.
All right, thank you. Oh, and then what have we done in our first one? Just do it quickly, Anisha. So Aditya, this is a normal differentiation question, right? So does this have anything to do with max and min?
Oh, yeah. Oh,
Okay,
can you
okay.
send me
So
the
just to
picture?
confirm, yeah, sorry, yeah, just to confirm. It's okay, yeah, sure thing. Right. Now, if there's something to do, then I know what's going on already. So never mind. Just continue. Just continue.
Oh, okay.
Right, just continue. Your product rule, say your quotient rule seems. Oh goodness me, Aditya, you make that mistake again. Stop canceling stuff when there's plus minus relationship. Stop it. Stop doing that mistake. You're being very random here. Oh yeah.
Oh, yeah, it has to be common with all the
Yeah, it has to be contained in all, right? Not just one, because there's a minus there, right?
Yep.
No, don't do that. Don't do that. Aditya, all this looks good. Now, why are you stuck here? Oh, no, no, you're not stuck here, which is good. All this looks good. So you have 2 points lah. Now, the question shouldn't stop here, right? What is the exact question?
It's to find the coordinates of the stationary points and determine the nature of each of the stationary points.
Correct. Who is maximum and who is minimum lah, which is a very normal thing to happen in a maximum minimum question. To be fair, do you know how you use the second derivation method? Is that what you like?
Yeah, I think the other method, like the table one, is a bit too long. Like, yeah.
Right. Let's see. Let's see. Right? You do it first, and then I'll demonstrate. Whatever you choose, I'm going to demonstrate the other method, and then you see for yourself whether who is faster and better for you. That's important. For you is what matters.
Okay.
Aditya, I cannot follow. Yeah, cannot follow.
Yeah, I'm just thinking right now.
Wait. All right. Okay. That is a yeah. But I am very happy that you don't simplify it, right? And the process of writing the -2 also is not necessary at all. You just type it in the, I'm so sorry, I said something wrong. Yeah, you have to write it down. I'm sorry. In O level, you have to write it down. Okay, right. You do have to write down. I'm sorry. Yeah. No, don't repeat. Don't repeat. Just put it in the calculator. Just put it in the calculator and tell me what happened. Right. That's the more important thing right now. Let me see how you put it in the calculator. Are you putting it with X or are you putting it with X or are you putting it with -2?
With -2.
Okay, then let me ask you again. I'm going to stop you here right now. If you put it in -2, then you have to change every -2 into zeros. Stop and think, Aditya, stop and think, right? You have to do that. Now, what do you do with zero? Do you plan to do it with the calculator or do you plan to do it manually?
Well, I thought of doing it manually.
Because zero is easier. Therefore, -2 just for calculator, correct?
Yeah.
Lucky you, zero is easy lah. Now, how about if the point is -2 and 5 in the exam, for example? What will you do?
Then I would like store and then AB.
I'm sorry, you what? Sorry, you do what?
I'll like store as A and B.
Then you use A and B. Okay, I understand. Okay, as long as you do that, then you know what's going on. Then go ahead and do your minus 2. It's okay. Please do it.
Okay, thank you.
Hello.
Yes, Inish, I can hear you.
Yeah.
Page 9 question. Yeah. Okay. I think you're correct with the 0. Okay, so conclusion is, Aditya?
So
Inish, why are we not moving, Inish? Inish?
I'm trying to understand the question.
Let me state first, because you might not have learned this, that both of them are gas. That's the only way this question works. This is a gas, and that matters a lot. This is also a gas, and that also matters a lot. This question is from OChem, and no other knowledge from OChem matters, except that these two things are gases. Aditya, let me see the message. Okay, Aditya, would you like me to demonstrate the table method, just for your comparison?
Yeah, sure.
Right. Show me your first derivative, please. Yeah, I'm gonna copy that. Right? I'm gonna copy that. Okay. If you like, you can count my time, but I'm gonna do this in a leisurely, relaxed pace. Yeah. Do you follow the Jamboard, page 3?
Yeah.
Right. This will be X and this will be X. I will test the first guy. I will need 3 columns, right? The first guy is -2, right? -2, am I correct? -2. So this is going to be -2 plus, and this is going to be -2 minus lah. So less than -2 and more than -2. The dydx of this guy is obviously 0. All right? Okay. I'm only concerned with these two numbers. Look, the other table is just for presentation one. Clear, yeah? Right. So if you can follow, then my mind is now thinking about -2, right? So -2 here. -2 here on the bottom will cause this to be a positive value. I don't really care what the value is, actually. But the denominator will be a positive value, okay? I can do this very fast. Will this be okay?
Yeah.
Now, -2 positive, -2 positive. Whether -2 positive, -2 negative, the same thing. Now, if I put a -2 more than -2 here, that means -1,9. So to make this easy, some people will write this as -1,99. And some people will write this as -2,01. Some people find this easier than -2 minus or -2 plus. Go ahead and do that if you want to. So I'm going to do that. -199 here and this and that. So at this point, I am very clear in my mind that the top guy is going to be minus. I'm very clear one. Do you know why?
Because
it is -1.99 times -1.99 correct or not? Square ma?
Yeah.
Whereas this one is -0.119 times 2 lah. 2.
Okay.
Of course, this will be a positive value, I have no doubt, but this positive value will definitely lose out to this negative value lah. Definitely one.
Yeah.
I don't have to know what it is. I just have to know it's negative, because then negative value over a positive is a negative value. People usually do this in calculator. I mean, I grew up without calculator. It's not a very difficult thing for me to do this in my mind. However, I will argue also that it is not difficult at all to do this in calculator. There, negative lah, right? Right?
Yeah.
I do this for the other side with my mind. I know it's a positive, so I don't know. So therefore, conclusion, this is a minimum point. Yeah. Is this the same conclusion as yours?
Yeah.
Yeah. Now, obviously, we're not surprised. It should have a same conclusion. Now, what do you do with the other point? Same thing, 3 column, x, dy dx, and then this will be 0, and this will be 0,01. This will be minus 0,01. Correct? Simple,
It
right?
wouldn't be a maximum if it's.
Oh, I'm so sorry. I'm so sorry. This is a maximum. I'm so sorry. The shape is what we're talking about. Right? This is obviously a maximum point shape. Sorry. Apologies. So, do we have a different conclusion, or do you have the same conclusion? Sorry.
No, I have the same conclusion. That's why I realized.
Yeah. Sorry. Yeah. Right. So then 0.01, and then doing the same thing, I will get this and that lah. Right. And then we show that this is a minimum. Then conclusion. Okay. It's not that fast, but it is very reasonably fast with the calculator input. I will argue that inputting this in calculator is faster than yours lah, because the double differentiation is more complicated. Something like that. Now, my question is more like this, just to make sure that you're making the correct decision. Most people like first differentiation method, not because of anything else. It's just because it's easier to do for them. I have no problem with you claiming that double differentiation is easier for you. You did it correctly, what? I mean, yeah, you did it correctly, right? So I have no protest. But are you sure the first differentiation is harder to you than the second differentiation method? Are you very sure about this?
No, it's not harder. It's just our teacher said that we have to use second differentiation.
From time to time, if the question specifically asks for it, in your, upcoming exam, a small test, they may devise a question. This one must use second. This one might use first. Let me explain what happened in the IGCSE, the O level. Most of the time, the first differentiation method is the easiest and least error method. First of all, because the first differentiation is already there. The second differentiation requires you to second differentiate, which will introduce some potential error. Of course, this time you're correct, so I have no comments. Something like that. Secondly, second differentiating can be easy, can be complicated. So sometimes you want to avoid it. It's not a foolproof method. Does your teacher present the second differentiation method as like the best method to do? Is that how she said?
No, he says that first differentiation is easier, but he's just asked us to do second differentiation.
All right. So as long as you do it with a clear understanding that not because it's the easiest, and therefore you can still do first differentiation method. You can, right? You can do first differentiation method. Okay.
He said that then, it's more for like IB.
Yeah. That's okay. All right. But as long as you can do both, I have no complaint. Right. Totally fine.
Okay.
Right. Feel free to move on. Right. Hopefully you can do a slightly more complicated question this because obviously you know how to do a basic min-max. You're totally okay. Can we go and do something harder? Like last time, you practice easy, then suddenly in your exam have to practice a lot of hard things. Right? Let's practice the hard things now. Right. Now, Ainesh, are you stuck? Ainesh, are you stuck?
Yeah, I got 7.
At this point, Ainesh, you're using the wrong formula. Okay, I'm going to discuss this very quickly, okay?
Okay.
You didn't use the formula for gas. Your mole is kind of bad that way, I guess. Yeah, so you didn't use it. You didn't use it.
24. 24 times 30 should be the mass, right? Or am I doing something wrong?
Oh dear, my goodness. Does this sentence make sense?
0.1 mole is always 24 TMQ.
An arrow.
Oh, okay. Yeah.
Tell me what's the MR of ethane?
MR of ethane is 30.
About right, yeah, correct. That's correct, yeah, good. So that's the mole of ethane. If you really want to, you can figure out the volume lah. If you really want to lah. So the volume ethane is equals to 20 over 30 times 24. Right? He say equal volume of propene, so this volume is equal to the volume of propene. Now, I don't see any of this step here. You might still be correct, but at this point, I'm confused with your working. I'm very confused. You didn't do what the question is saying, like, oh, the volume is equal ma. Oh, okay, then let me go and find the volume if I can lah, which I can, right? I probably should lah.
Hey, what is going on?
I don't know. You ask yourself that.
How is the volume of the 20 by 30 times 20?
Why do you say yes to this and then everything else becomes confusing? Why is it like that?
No, I understand. Okay, I understand this. I understand this, but I don't understand how that comes to this step.
Read this sentence to me again.
One more.
Read this sentence.
Yeah, sure.
That's not enough, really.
Hmm?
That's not enough. That's not enough for you to understand this, really. Aditya, are you having trouble finding difficult questions?
I do have. Just looking
All right,
through.
all right, okay, sure.
Oh, okay.
I don't get the 30 times 24 lah. 30 seems the MR. You write down 30 is MR, write down on top of 30 is MR.
I thought the mole was 24.
Why do you say that? Why do you even think like that? 24 is 24 dm cubed. So how did that become mole?
I didn't see the 20 grams. I just don't know what I was doing, honestly. Confused. I didn't see the 20 grams. I didn't see that this was different. I just bad. But okay, I understand now.
Can you continue from here? Doesn't mean that you understand. I haven't found the answer lah,
Yeah.
but I did most of the work already.
Hey, mole times.
Mole times MR is the mass. Yes, I know. So I know. Like why are you stuck here?
Okay, my answer is
Tell me what's the mole of propene?
2/3.
How do you know that?
Because equal.
What is equal? Sorry, tell me just to be clear about this. Just to be clear. It's equal volume, you know. I'm testing you, yeah. It's not equal mole, okay? It's equal volume. Do you have problem differentiating volume and mole?
A little bit.
What do you mean by a little bit? One is called volume, one is called mole.
So you. What? Isn't this it's not MOLE, just MOL.
Yes. Yes, there is a mistake. Is that a problem?
Yeah, I was so confused. Okay, now I understand.
Okay. So how does that solve your problem with volume and mole?
Okay, so the mole MOL is 20 dm3. So MOLE is equal to concentration times volume. That's different. this one is yeah, this one is
you are, and you know, I mean, if you think that's the problem,
yeah, never mind, that did not solve my problem.
if you think that, Aditya, tell me, why are you stuck here?
It's asking me to find A and B. Oh, wait, why don't I
There's
put
no
in
B, yeah? There's no B here.
B, this
All
B?
right, B.
B?
Then I think he should be giving you one more information here. There's a maximum. Oh, no, no, no. It's enough. No, it's not. No, it's not. Yeah, it's not. It's 7 or B? Which one?
It's 7, 7.
All right. So are you stuck here?
A bit.
Let me type something for you.
Oh wait, I
Ganesh.
think I know what to do. I think I know.
Okay, okay. Oh, go ahead, go ahead. I will be happy if you could do it yourself, definitely. Ganesh, are you still stuck?
Yes.
You have the volume, right? Tell me what's the volume?
$24.
Tell me how many mole is ethane? Ethane?
2/3.
How come I know the mole of ethane? Because I have two things, right?
I have the mass and I have the
MR. So I know the mole of ethane. Now I claim that I also know the volume of ethane in my work, which is not 24. You just spend time understanding why this is so right now. Are you saying that you don't get it?
I don't get it. I thought I understood, but I didn't.
For all guesses, just read this. Just read this. Just read this one more time. For all guesses, read it for me.
Oh. Okay.
Like read it loudly.
But how does 2/3 mole of the 24 dm cube equal to volume? I don't understand that.
Bloody nonsense. I am not. Just read it loudly for me.
A mole is always 24 dm cube.
For all guesses. For
all gases.
So if I have 2 mole of gas, what's my volume?
Huh?
Just answer the question, please.
2, but I don't understand. I don't understand why it's 2.
What are you talking about? 1 mole for all gases, 1 mole is always 24 dm cube. If I have 2 mole, why is my volume 2?
No, then it's 24.
Oh, bloody. Repeat after me, Agnesha. For all gases, 1 mole is always 24 dm cube. 2 mole is therefore 48 dm cube. Would you please repeat after me and then see for yourself whether it makes sense or not? Ganesh, I'm not asking you to understand it and then repeat after me. I'm asking you to repeat after me, then try to understand it.
Okay.
Repeat after me, please.
Okay.
What are you talking? Repeat after me. For all gases, 1 mole is always 24 dm cubed. So if I have 2 mole, it will be 48 dm cubed. Repeat after me, please.
Okay, if I have 1 mole is 24 dm cubed, so if I have 2 moles it's 48.
Does that make sense or not?
Okay.
Okay means what?
I mean, yeah, it makes sense.
So if I have 2/3 mole, it is 24 dm cubed. Is that correct or not?
Okay. Yeah.
What do you mean? Should be. If I have half a mole of a gas, what's the volume? Finish.
It will be 12.
So you have 2/3 mole. What's the volume?
What do you say?
If I have 2/3 mole, what's the volume?
The volume. And the only thing I don't understand is how does it go from 1 mole being 24 dm cubed and then like you find the amount of moles, then how is that volume? Is it not just the amount of moles?
Do you ask basic questions before the exam? You want to know about the salt bridge? Spend half an hour, spend 1 hour. Now you're asking for something basic. Then we're spending 20 minutes just circling this point. But you just be practical the day before exam, finish. If you cannot, I'll explain it for you. Finish. Can you be practical and just accept this? If you cannot, I will explain to you. What is your choice?
Okay, fine, I'll accept it.
So what is 2/3 mole? How many volume is it?
8.
So what's the volume of ethane?
8.
And what's the volume of propene?
Also 8.
Do you want to know the mole of propene?
Nah.
You don't want to know the mole of propene.
I want to know the mass.
Just kill me. Right. Okay. All right, then you have the mass now. All right. Now let's move to the next question.
Wait, then how do I do the question?
Do you want to know the mole of propene or not?
If it helps me find mass, then yeah.
Yes or no?
Yeah.
Do you have the volume of propene?
Yeah.
Can you find the mole of propene?
I don't know.
All gases. Mole is connected to volume. 1 mole is 24 dm cube. If you know the volume, can you know the mole?
Yeah.
Can you therefore find it yourself, the mole of propene?
It's also 18.
The volume of propene is 18, so the mole of propene is 18. Come, let's move to the next question already. Really. There's nothing that I can teach you in 15 minutes at this point, really. I can't. Just know that you have a basic problem with gases lah. So you can pray that tomorrow there won't be any gas question. To be fair, gas questions are a bit rare lah in electrolysis. Does happen from time to time. It'll be more with OChem, no? As this is OChem. Yeah. Let's move on to the next question, Hainesh.
You ask more questions also. Let me try to understand this for like 3 more minutes.
Then answer the question, no? You have the volume is 18. Why do you keep insisting that volume is equal to mole? Why do you say that?
So if our volume is 18 dm cube, then
your mole is
2/3.
Okay, so you have the mole of propene, right?
Yeah.
All right, then what is it then?
Then I multiply by the ml.
Yeah, by the way, it's not 18, okay? By the way, it's 16. Why do you keep saying it's 18? Yeah? Do you use the calculator?
Oh no, I did.
Just use the calculator, please.
Yeah, it's 16.
So do you have the mole of the propene?
Yeah.
So can you find the mass of the propene?
Yeah.
Okay, all right. Thank you. If you think you're right and you don't need all this, just know that you were very, 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 very lucky. Just know that. Try betting on your luck tomorrow. I usually don't think that's the best strategy. I don't think so. Right? Can we do the next question, please?
Yeah.
Aditya, why are we stopping in this 15 minutes? Can you look it up?
Oh, sorry, I was thinking about.
So have you done the A and the B thing? Have you done the A part? Can I see how you do it?
Yeah.
The previous question. Can I see it?
Oh, I've got a chemistry test next Wednesday, so I don't think I can have class Tuesday.
Let's talk about it later.
Okay.
Yeah, your method is correct. Okay, right, cool. Okay, now the A and B. So the A and B is slightly more difficult, right? Can you handle it? Right. A and B should be an exam level question, so I'm happy that if you can do this, if you can.
Okay. I'll try my best.
Anish, do you have trouble finding more questions?
Yeah.
We don't have much time really. Let's just hope that tomorrow you don't have a lot of more questions lah, because that's what the past exam says, no? I hope that will be the case. Okay. Right.
Me too.
Let's just do other questions lah. We have been seeing a lot of paper right now in order to find the more question where there isn't much. Okay, can we just do something that looks difficult for you so that we can learn more?
Okay.
Yeah, I did it. It was actually easy.
Yeah. Let me see. Yep. Yeah, okay. Hey, wait. Yeah, okay, yep.
Just
Oh,
checking
well, that
out
turns out to be quite easy. Yep. Oh, most definitely your methods are fine. Yeah, most definitely good.
Yeah, they're correct.
They look easy partly because the equation is easy lah. Having said that, your method is correct and that's something lah. Right? Waiting for a harder question. What does a harder question look like? A harder question looks like this. They give you pictures. They tell you this, they tell you that. Then they suddenly ask you to do something to the picture, usually a cone lah, a box lah, a trapezium lah, don't know lah. Suddenly all those things enter what is supposedly a very simple max-min question. To be fair, a max-min question is always very simple and standard. Yes. The difficulty lies in when they put in drawings and everything. Have you encountered those kind of questions?
No, I mean I've got those questions with like a piece of wire and like a cuboid in a pyramid and yeah.
Maybe.
But
do you find
like
that to be?
I mean, yeah, it's challenging. It's way more challenging than that. That is just horrible.
If you find that to be horrible, either let's do that question again just to check whether there's a problem or not with your understanding, or find something similar lah. Or just go to IGCSE past paper and see what the standard is lah. Because there is no point for you to practice more on the same question. It is not supposed to be very complicated. You got it anyway. You totally get it. We need to practice the harder thing lah.
Okay.
Anish, is it difficult to choose a question? Like, I mean, this is another 4 minutes. There you go. Oh, okay. Tell me why this looks difficult to you.
Because it's a type of question we haven't done.
Why is this looking new? Tell me the new thing for you.
4 different electrodes in one.
Right, instead of 2. All right. Anything else?
A different electrode. What's it called? Solutions. But we did that already.
Electrolytes.
Right.
Yeah. All right. Okay. Sure thing. Same thing. Okay. Candidates. Who wins? Electron flow. Same thing one. Meaning when it is hard, stick to the principle. I need you to do that immediately. Electron flow and candidates, please.
Okay.
You're taking too long to do the important things in exam. You're not supposed to waste time. Do it right now.
Mr. Phillips.
Yes, Aditya.
Should I do like the ones where like there's water going into a tank and stuff?
I'm sorry, I cannot hear you. You're saying?
Should I do those questions which are like water flowing into a container?
Yeah. You probably should. You probably should do that.
Okay.
Probably. Okay. Right. That seems to be the additional thing. There's the electron flow, Anish. Now the candidates, please. You can put it on paper. Yeah. Please don't write it on On mouse, please. On paper, please. Candidates, please.
I have to do it separately for each cell, right?
Just do it. Just do it quickly, please. With no hesitation, please. Stop hesitating and start doing things. Candidates, please.
What am I doing?
Aditya, you send me. Now, Aditya, this is a rate of change question, right? Rate of change question is not a maximum minimum question. You told me that this is not covered. Let me confirm this with you. Is this covered or not? This is. So there are three types of application: tangent normal, maximum minimum, and rate of change. Right?
Yeah.
In general, if we don't understand, rate of change is the worst. If we understand, it becomes kind of okay. No? Can you do this or not? Should I advise you, or you just do first?
I think we just touched on rate of change in class.
So is it in the exam or not?
Not in the test, no.
Oh, then not in the test, then maybe not for now. Maybe not the rate of change question. So this kind of question, but for maximum minimum, which should be obvious in what they ask. So it still looks like this, but maximum minimum.
Rate of change coming or not depends on whether he covers it by Friday.
Which is crazy. Cover it and immediately exam. But okay, never mind. We'll see. We'll see.
Or I don't know. He'll probably do it next week. He's a magic man.
Magic in a good way or in a bad way?
In a good way. In a good way.
Good is
not
good.
A bad teacher though.
All right. I'm happy to hear that.
Compared to some of the others in our school,
he's quite good.
One of the
Understood. Yeah. Okay. Glad to hear that. Now, Ainesh, just label the P and Q for me so I'm very clear what you're doing. Which one's P and which one's Q? Just to be clear. P, Q, R, S, right?
Yeah.
Which one's P here in your candidate list? Okay, so in a P, you're attracting the OH minus as the candidate, and then Cu, and then go up, please, go up. And then by right, there's an SO4 2 minus, but of course they never win. So I'll pretend that doesn't. Okay, so OH minus wins, not Cu. Okay, OH minus is going to give up electron, not Cu. Am I correct? That's your thinking.
Yes.
Now in your Q, your candidate is Cu2 plus Cu and H plus. That makes sense. And Cu is going to win. Cu is going to win in what kind of competition?
Huh? What kind of competition?
Yeah, they're competing, right? So they'll win for what? He's winning for what?
I feel like I did this one.
Well, why do you draw the electron flow and then you don't use it? Why is your thinking very disjointed? Well, you use the electron, you draw the electron flow, and then you don't use it. And then now you wasted 5 minutes of your exam time already. And you're now redoing. Wow. It's really like you're doing this for the first time. What's going on? Never mind. Never mind. We gotta struggle. What else can I say, right? Yeah, Aditya, the hard part is usually part A, which has nothing to do with maximum minimum.
Yeah.
So let me clarify this with you, yeah? Just to be very clear, you can do B immediately without A. Do you know that?
Yeah. Oh, but
Why
it
do
is
I
not that
ask you
hard
to do
either.
that?
'Cause- Oh,
I hope so. At least not for this question, but this is not exam level lah. I mean, it's just a good practice lah. So good for you lah. Right? If you can do A, that would be nice. Very, very nice. Let me tell you a secret about part A. It's always not additional math. It's always the normal math. Always.
yeah. No, I'm like
So switch.
a bit confused on the picture because I don't know, like, are those dashes the wall or is it like the fence? Is it like spikes on the fence? I can't tell.
With a fence on 3 sides. Did you read the English side? Did you read the English sentence?
Oh,
Because I'm doing the reading for you, and that's not okay in exam lah. You should be reading lah. Your
yeah.
question is wonderful. That means you're analyzing the picture. But of course, being a quick question maker, the question maker already thinks about it and answer it for you lah. So I'm glad for your question. I'm very happy for it. But let's look at the answer lah. The answer is okay. Right.
So it's a top view, like it's a top view of the fence.
They don't tell you lah. They don't tell you. Fair. They don't tell you, but you can assume what is most reasonable lah.
Okay.
Okay. I know they don't tell you. That's why you assume. But I think your assumption is not bad lah. Right? It's not bad.
Okay.
Now for
Okay.
P, your Anesh, let me repeat this. Just stop. Just stop, Anesh. Just stop. Just stop.
And who wins? U2 plus or H plus?
Look. P. In P, your candidate list is CU and OH minus, right?
Yeah.
And now you're claiming that CU wins, right? So in what competition? Just answer that, please. What is the competition in P? Okay, because the electron flow is out now, so you're correct lah. So you're claiming that Cu will lose electron, not OH lah. Right? Just to confirm that's what you're claiming lah.
Yeah.
All right. And whether you're right or wrong, well, at least you're thinking about the right thing lah. At least lah. I don't know whether you're right or wrong, but at least you're thinking, oh, Cu is losing electron. Oh, Cu is going to win, not OH. Okay, at least you're thinking, right? Okay, now the Q list. The Q list is your candidate is Cu2 plus, H plus, and Cu. I can appreciate the candidacy. Now, what competition are they in?
Gaining.
What competition are they in?
Gaining.
Electron. So who will win? Are you having trouble there?
Yes.
Why are you having trouble there? You must know lah. You must know why. This is very likely to happen. Anyway, good job, Aditya, right? I mean, you're doing it correctly lah. 3 point, right? Can I ask you to not do the maximum area? You already know how to do it. Okay? Can I ask you to do more of this kind of question than the show part? Okay? Maybe one more.
The show part?
Yeah, just show. That's the part where I think in exam it will definitely happen. In locals, it will be slightly more complex than this lah. You practice that, then the whole thing is yours, huh? Right? The B is just you know one, huh?
Okay.
You practice it by yourself. Anesh, why do you have trouble deciding the winner of recipient of electron?
Because I'm second guessing everything now.
Between who? Between the 3 candidates?
Between Cu2 plus and H plus.
A fair thing, you narrow down to not Cu. I can respect that. Why is H plus and Cu2 plus giving you trouble?
Because Cu2 plus is less reactive, but H plus, there is more H plus.
How do you know that there is more H plus? Because they never tell you this is dilute or this is concentrated.
My teacher said that it's naturally
write your note. Look at your note. The dilute concentrated thingy is for the negative ion, not the positive ions. The positive ion don't have this problem. Don't ask me why your syllabus defines it that way. Because your syllabus defines it that way. Only a problem for negative ions. When you write down your notes, you certainly need that. Go back to deciding quickly. Okay, Aditya, I cannot see the question. Yeah, I can just follow you, right? Yeah. Okay, understand. Okay, right. So give it a try. So CO2 plus will win. Okay, you have at least decided your winner. Okay, so next one. Don't decide the winner without the full candidate list. So Ag2 plus is Ag plus. You gotta remember that for tomorrow. You have decided the winner. All right. Now, can you answer the question? P and you're saying that P and R increase in mass.
No, the decrease in mass. Oh, increase would be
Right.
increase would be Q and S.
Try to read better tomorrow, yeah?
But P and R would decrease in mass, right?
Yes, that will be correct.
So Q and S will increase, but this will react, become Cu and then coat. And this thing.
Yeah. All right. You know that already. Okay. If your candidate list is correct and your winner is correct, then your answer is correct. No? Better be sure about that.
How do I answer B? At which electrode will the mass increase rate? So it's either
write the reaction for Q and S, write the reaction, and you will see who very clearly. Show question. Your reaction is correct, right? Is it balanced? Just to check.
yes.
Now, by these two reactions, you should know the answer. This is your final learning for today. Try to figure it out before I tell you. No. I said something wrongly. I said that with this and the MR also. With this and the MR also. So you have to consider the MR. Yes, you still have to consider the MR. You still have to consider. Never mind. Use these two reactions first. Use these two reactions.
With the two
In these two reactions,
I think it's silver because lesser electrons is required. To make
very good. Correct. So let me put it another way. Put 2 electrons for Ag. 2, 2, 2. Put it there. Put it like that. 2, 2, 2. Right? Okay. Nothing mathematically wrong with that. For 2 electrons, you get 1 Cu, but you get 2 Ag, which is a big deal, right? Big deal. So that's the concept. You get the concept. You totally get the concept. However, this is not math. This is mole. For 2 moles of electron, I get 1 mole of Cu and 2 mole of Ag. Do you understand? This is mole, not mass.
Yeah.
Therefore, you must finally check with the MR. If the MR of Ag is way below, then you might still have to choose Cu, even though the mole is greater. Am I making any sense?
Yes.
So write that down formally. For 2 mole of electron, you get 1 mole of Cu and 2 mole of Ag. Write that down. And then check with your MR, which you will get from a periodic table, and then finally confirm your answer. Aditya, are you stuck or are you correct? Sorry, are you stuck? Oh, you showed, yeah, you showed already. Okay. Not the hardest question, but I'm happy that you're practicing this. Now, have you been practicing the show part?
Yeah.
Really? In school? Really? In class? I'm quite happy if you do.
Like he just introduced it to us, like last lesson.
A bit, yeah.
Yeah, because he didn't want to move on just yet, and
correct.
he
It's a
wanted
little
to,
bit.
because the syllabus was like being a little debated for the test. So just to
Right.
just to keep us occupied for the lesson, he gave us
Hmm.
the practice show question,
Right.
because he
So
said it'll be useful.
for prelims lah, you'll be having prelims, I think, right? For prelims.
Yeah.
Yeah. So for prelims, the
Oh,
question will be.
my dates there. I'll send it to you.
No, I know. Yeah, it's still a bit long. No, no, it's good that they have decided the schedule, though. It's not, messy lah.
Yeah.
So for the prelim level, therefore for the IGCA level, the show will be harder than this. Not a lot, but definitely harder. So I'm happy that you're here lah. I'm happy. I'm happy. So that means we are ready to move on whenever we have the time to move on to the prelim level. I'm happy that you're here.
Okay.
Okay, good job for today, Aditya. All right, I'll see you. Bye bye.
See you. Bye bye.
So yeah, Ainesh, what's your conclusion after knowing the MR?
Syllabus MMR is more, so it doubles down on the fact
So
that increases.
so whose mass is greater?
Silver. So
Correct, because just say that mass is mole times MR lah, right?
yeah.
Mole times MR. So mole smaller, MR also smaller. Confirm the answer already. Confirm the answer is silver. And
No.
therefore, this is a mole answer lah. Therefore, this is a mole question. Therefore, from electrolysis to mole.
I see.
Right? And you have to present it that way. You do have to present it. You don't have to say anything. You present the numbers and the formula and you'll be correct. That's the explanation. Okay? You can write English if you want to, but it's not necessary for this question.
Yeah. Okay.
Okay?
Also, is the order of like the beakers of the cells any different? Like, does it cause any difference? No, right?
If I swap it, it wouldn't matter.
Okay.
That is a good question.
Is there any scenario where it would matter?
If you swap it fully, all the electrode and all the electrolyte, if you swap it fully like that, no, it doesn't. Even though the electron seems to reach the right-hand side first, then the left-hand side, right? So maybe we think there's a problem. Maybe we think there's a difference. There isn't. There isn't. At all. At all. At all.
Okay.
Electricity doesn't work like that. Like I arrive S first and Q first. Electricity actually does not work that way. Electricity works everywhere, move at the same time. I'm not sure how to explain that in O level, but no, it doesn't matter. And your question is a good question. Right? Anything else?
No.
I guess I won't be seeing you tomorrow.
Yeah, probably not.
Yeah. So take a rest tomorrow. Take a rest tomorrow. I'll see you on Sunday. Bye.
Bye. Thank you.
You too.